In this tutorial, I will be demonstrating how to use Microsoft Excel to perform basic mathematical operations and also to use formulas in spreadsheets. When using Excel to perform mathematical computations, we will have to enter the computation in the form of a one-line equation or formula. We always will begin these formulas in Excel with an equal sign. So for instance, to add 4 plus 2, we will enter in the cell equal 4 plus 2 and then press enter. Now if we highlight cell A1 again where we just entered our formula, notice that the result of that mathematical operation 4 plus 2 is what is displayed in cell A1. But if we look up in the formula bar, we see the actual formula that was entered into the cell, equal 4 plus 2. Now what would happen if instead of entering equal 4 plus 2, we forgot the equal sign and just typed in 4 plus 2? Hit enter. You notice now what is displayed in cell A1 is just 4 plus 2. It does not perform the mathematical computation of addition that we asked for because we did not begin with an equal sign for that formula. So it assumes then what we've entered is just text. Now if we make that mistake, simply highlight the cell, move your cursor up to the formula bar, click in front of the 4, and include the enter sign. By the same token, instead of adding 4 plus 2, we can subtract 4 minus 2. And we see the result here is 2. Or if we wish, for multiplication, we use the asterisk. 4 times 2 is equal to 8. For division, we'll use the forward slash. And to raise any number to a power, let's say we wanted to square 4, we will enter equal 4 caret 2, and that should square 4 and equal 16. When working with the formulas in Excel, we have to keep in mind what the basic procedures are for executing mathematical formulas. We solve from left to right, but addition and subtraction are performed after multiplication and division. For instance, let's say we wanted to take the average or find the average of 3 different numbers. Let's say we wanted to find the average of 10, 20, and 30. So if we just merely type in equal 10 plus 20 plus 30, and then we divide it for how many numbers we have in our formula, divided by 3, and hit return, notice the result is 40. The reason for that is if we go back up to our formula bar, we notice that it will first of all perform the division of 30 divided by 3, which will result in 10, and then it will perform the addition of 10 plus 20 plus 10 again for 30 divided by 3. Instead, what we'll need to do is we'll need to add parentheses around the 3 numbers that we're finding the average of. So equal 10 plus 20 plus 30 divided by 3. Now what this will do first of all is it will perform the procedures within a parentheses, and then it will proceed to work outside the parentheses and perform the division. So it will take 10 plus 20 plus 30, which is equal 60, divided by 3, and that should give us our average of 20. This is using Excel as we would a calculator. Instead, Excel's versatility really comes out when we begin to use formulas that reference data in individual cells. For instance, let's assume that we have 3 students who took an exam. And we want to find the average of these 3 students. One received a 95, another a 72, and a third an 87. Let's say we want to report the average for these 3 students. and enter that information into cell C7. What I could do is to enter the formula equal, open parentheses, 95 plus 72 plus 87, close parenthesis, divided by 3. Hit return. This formula is not very flexible. Let's assume that I actually made a mistake in entering in student 2's exam, and that student actually received an 82 instead of a 72. So let me correct that entry to 82. But we notice with the new number, 84.7 is still the average that's reported. And that's because now our formula has not updated the information for that new exam score. We'd have to go into our formula, change 72 to 82, and now we find the average is 88, actually, of these three students. Instead of including the actual values of the exam scores we wish to add together, it would be more flexible if we referenced the cells in which these exam scores are entered. So for example, student 1's exam score is entered into cell C3. Student 2's exam score is entered into cell C4, and student 3's exam score is entered into C5. Hit enter, and now we still see we have the result of 88 for the average, but let's go back and change that 82 back to a 72 as we originally had it. Now you notice then the average automatically is recalculated with that new data included. The cursor to highlight the content of cell C7, we notice that the result is 84.7 that's reported in the grid, whereas the formula reported in the formula bar is the formula we entered of C3 plus C4 plus C5, those added together divided by 3. Now to check to see are we using the cells that we think we're using in our computations, double click on the cell where the formula is entered, C7. Now you notice what results is in the cell itself in the grid the formula is reported, but also it's color coded. So we see here that cell 3, which is outlined in blue, plus cell 4, which is outlined in green, plus C5, which is outlined in purple, are the values that we wish to add together. Let me enter that to get out of that procedure. Let's assume that what I did is I used the wrong row reference, or column reference in this case, for the formula. You notice we know that the 60.67 is the incorrect result for the average for these three exam scores. So let's see what mistake I made. Double click on the formula I've entered in C7, and you notice the green cell in that computation is out in D4. That certainly is not the piece of information we want to include. So that tells me I need to go back up and change D4 to C4, and you notice now we see the green does highlight the contents for student number 2 exam. Modify our formulas through the use of functions. Excel has created a set of procedures that can be executed with a simple word. For instance, if we go back to our formula, I'll demonstrate the use of the sum function. Equal sum is the function name, open parentheses, and in the parentheses we identify the range of cells. The first cell is C3, colon, C5, close parentheses. The array C3 colon C5 indicates include all the values from cell C3 through and including cell C5 for this operation. Now the operation to perform is to sum those values. In that case, after we have summed those values, then the regular mathematical procedure would performed of dividing the sum of those values by 3. Now an easier way of entering in the array itself instead of typing in C3 colon C5 is to just move your cursor to the cell of the very first value to include in your computation, click left mouse button, hold it down, and now drag to highlight the last cell in that range. And while we see that the array C3 to C5 is added into our formula up in the formula bar. Hit enter, and there we see our result is 84.7. Now arrays are used in this way when we have all of our data for a given procedure that are together, listed consecutively within the same column or within the same row. Now that we have the basics of entering formulas for computations in Excel, I'm going to apply these formulas to the hypothetical grade sheet for Political Science 556. So I clicked on that second tab that's labeled Paul's 556. And the first thing I'd like to do is to find out how the students did on average for each of the 3 exams that were administered for that semester. So I'll type in the label averages in cell B10. And in cell C10, I'm going to compute or enter a formula to compute the averages for the 4 students on exam 1, equal, to begin my formula, open parentheses, C5 plus C6 plus C7 plus C8, close parentheses, and divide by the number of cases there are, and that will be 4. Another way I can do it is using functions. Equal, sum, open paren, I'll click and drag to highlight the range of values that I would like to sum, close paren, divide by. Now this time I'm going to use a second function. I'll use the count function, count, open paren, again the range, C5 through C8, close parentheses, and what the count function does, it counts how many valid numbers have been entered in the range D5 through D8. So if I have a very long class roster, I don't need to count how many students there are to compute the average. This count function will find it for me. Hit enter, and I have an average of 82.5. So that's a little bit easier than what I did for finding the average for exam number 1. But I'll show you an even easier way to compute averages for exam 3. I'll simply use the average function. Equal, type in average, open parentheses, now highlight the range of cells that contain the data that you would like to average, and close parentheses. And there we have a 90.5. So students did better in the class on the first exam, and they did worse on exam number 2. The next thing I'd like to do is to compute each student's final grade for the entire semester. I'll move the cursor to cell G4, type in final average, make that a little wider, and I also will format that cell with the alignment. I'll choose to wrap the text. There. Now, exam 1, exam 2, and exam 3 will each be given a weight of 30% of a student's final grade, and participation grade will be 10%. So I'll type in the formula equal. I'll take exam 1 for student number 1 times 0.3, representing 30%. Add to that the score for exam 2 in D5 times, again, 0.3. Add to that their exam score for number 3, again, times 0.3. And lastly, plus the participation grade times 0.1. Now my weights, 0.3, 0.3, 0.3, and 0.1 should all add up to 1. Hit enter, and I see that the student's final grade is 83.4 points. To compute the final averages for the other 3 students, I could type that same formula into cells G6, G7, and G8. but it'd be a lot easier to just copy and paste, and let's show you how to do that. First, I'll click on the cell that contains the formula I wish to copy. That's the sourced cell. Now I'll come up to the clipboard portion of the menu, click on the copy button. I'll come down and click in the first cell of the destination range, and while holding down the left mouse key, drag that to highlight the three cells, G6, G7, G8. Go back up to the ribbon, the clipboard portion of the ribbon, and left click on the paste button. Now you notice that when I highlighted the cell G5, a flashing dotted border appears around it, indicating that this is the cell that is the source of the formula. Now let's look at each of the formulas. We see the formula entered for in cell G5, which is what we put in initially. Then as we copy it down, you notice it adjusts for each row that we copied it down. So instead of using all the information for student in row 5, Thomas Stephen, to compute the average, it now in cell G6 is going to use all the information for Alexander Suzette, and then in G7 is going to use the information for Richard's Billy Joel, and lastly in G8 it's going to use all of the exam scores that are entered in row 8 for Rasmussen Betty. But I can make the formulas I just entered for computing final averages even more flexible. You notice one of the problems that we have here when we look at these formulas is I've entered in the weights of 0.3, 0.3, 0.3, and 0.1. I can make that even more flexible by entering in cell references where those weights are stored. Now, why would I do that? We noticed that in exam 2, students did almost 10 points worse than on exam 1 and exam 3 on average. Let's assume that one of the things that happened during the exam period is there was an awful lot of noise coming from a room next door. And I realized that that put them under an awful lot of stress. So what I'd like to do is play with the weighting and reward these students to give them a grade that better reflects what their knowledge of the subject matter actually was. So I'll create in B11 the label weights. I'll type in the weights as they currently are, 0.3, 0.3, 0.3, and then 0.1 for participation grade. I'll go back up to my first formula in cell G5, and I'll delete that 0.3 and instead click on the cell that contains the weight for exam 1. I'll do the same thing for exam 2, delete the 0.3, and now click on the cell that contains the weight for exam 2. Do the same thing for the third 0.3 and click on the cell that contains the weight for exam 3. And lastly, I'll delete that 0.1, the weight for the participation portion of the grade, and click on cell F11 that contains the weight for participation and hit enter. Now you notice the result is the same for that first student because we're using the exact same weights. Now I'll copy that formula that we entered into cell G5 that contains nothing but cell references into the other cells, G6 through G8, where the other student final grades are. I'll highlight the cell where the original formula is that I wish to copy, the source cell. I could move the cursor up to the clipboard portion of the ribbon and click on the copy button as I did before, but this time keeping the cursor over top of G5, I'll click on my right mouse button and move up towards the top, which is just out of your screen I think, and click on the copy command. Now I can drag down, highlight the destination range G6 to G8, again use a right mouse click, and now I'll click on the very first paste button. Now you notice the problem. Now we see final averages of 0, 0, 0 for the three students. Well, what went wrong here? If I click on the first formula in G5 and we match up all of the colored boxes with the individual cell references and the final average, that formula looks just fine. Let me enter to get out of that. Now I'll double click on the cell that's entered in G6 and we start to see our problem. While the grades for Alexander are listed in cells C6, D6, E6, and F6 as indicated in the formula, the weights are still in cells C11, D11, E11, and F11. But as we notice here in the formula, it's trying to find that information in cells C12, D12, E12, and F12. The reason for this is when we copy from one cell down to the row below it, it adjusts all the cell numbers, the rows, by 1. So it increases from C5 to C6 and also from C11 to C12. But we want to keep the references to the weights constant. Thus far, what we refer to these are relative cell references, that it will adjust the number in the row, or if we copy across rows, columns, it will adjust the letter based upon where we're copying the formula to. But I want to keep that cell reference C12 fixed. Especially what's important here is to keep the 12 fixed. How we fix a cell reference so it does not change when we copy it into other destination is we move the cursor in front of the parameter I want to have fixed. I could do this in front of the C and also in front of the 11 and enter in a $sign. A $sign refers to a fixed reference. I'll do the same thing for D11, also for E11, and also for F11. Only need to fix the row numbers because we're only copying the formula down into rows below. I'll hit enter. Now I'll show you another way of copying formulas into cells below them. If I move the cursor, once I highlight the source cell, and move it to the lower right hand corner of that cell, G5, you notice the cursor changes from a large plus sign that normally is into a small plus sign. This is the fill handle. Now if I hold down the right mouse button, click and drag, now release. It has now copied that formula into cells G6, G7, and G8. Probably the easiest way to copy information into adjoining cells. Now let's go back up and click on the cell in G5, and we see that that is the formula we entered in initially. Move the cursor down and select the cell that is in G6, and we notice that the references to the individual exam scores has changed from C5, D5, E5, and F5 to C5, A6, D6, E6, and F6 as we wanted. But these references to the location of the weights has stayed fixed. They're still looking in cell 11 for each of those weights. We move down once more, and again we see that while the exam scores used for the computation have adjusted to the new student row, the place where the weights are kept has not changed at all. And so that results in an appropriate formula for computing all of these students. Now the value of this is I can weight that second exam that the students did really poorly on less. I'll put it a weight of 20%. Hit enter. And now let's increase the weight to 35% for exams 1 and 3. The weights still add up to 1 or for 100%. And now I can see what the effect will be by changing those weights. Now I see that student Thomas Stephen has 86 for an average. Alexander Suzette has an average of 92.7. Richards has an average of 88.6. And Rasmussen an average of 91.2. Let's go back to the original weights I had before. and you notice that it automatically recalculates the final average. So what I can do is enter in different weights and ask, what if these weights were different, what would the result be? The result is now different final averages, and that's why we often refer to spreadsheets as what-if analysis. In this tutorial, I have introduced 3 functions that have been created in Excel: the sum function, the count function, and the average function. In a complete list of the functions that can be used in Excel, move the cursor and click on the Formula tab, and on the Formula ribbon you'll notice a section that reports the function library. The ones I'd like to illustrate to you here is this set of functions, math and trig. Click on that and you notice that we have absolute value, cosine, sines, and other sorts of functions. Just scroll down to see all of them that exist. It may also, in some courses, utilize financial functions, as well as time and date functions that exist.